Welcome to my channel, DNA.12 Education.
Yeah, welcome again to my channel DNA.12 Education. Our topic today is angle of elevation and depression. Mathematics series, angle of elevation and depression. Okay, students, before we go to any questions, we are going to solve any question, of course, yeah. But for the first, I want to inform you what is angle of elevation and depression. In mathematics, the term angle of elevation denotes the angle from the horizontal upwards to an object. Once again, the term angle of elevation denotes the angle from the horizontal upward to an object. An observer's line of sight would be above the horizontal. The term angle of depression denotes the angle from the horizontal downward to an object. Once again, the term angle of depression denotes the angle from horizontal downward to an object. Note that the angle of elevation and the angle of depression are congruent. The angle of elevation and the angle of depression are congruent. Look at the simulation below. Okay. Yeah, this is a boy is standing on the sand or the ground. She's looking a plane above. Okay. Look at the diagram. Okay. We call this one is theta. Okay. Or the angle of elevation. Yeah, we call this angle of elevation. The elevation denotes the angle from the horizontal upward to an object. So this is very clear. We call this angle of elevation. The second term is the boy is looking a dog downward. Okay. The term angle of depression denotes the angle from the horizontal downward to an object. Let's say this one is beta. In mathematics, we call this angle of depression. Angle of depression denotes the angle from the horizontal downward to an object. Very clear, right? Angle of elevation and depression. Once again, angle of elevation is upward from the horizontal line, and angle of depression is downward from the horizontal line. Okay, students, we go to the question 1 to make everything about the angle of elevation and depression very clear. Okay, this is the question. In the diagram, TF is a vertical building on a level ground ABF. Where AB is 80 meters, the angles of depression of A and B from T are 32 degrees and 43 degrees respectively. Once again, the angles of depression of A and B from T, okay, are 32 degrees and 43 degrees respectively. Find the distance AT and the height TF of the building. Very clear, right? Okay, students, the first step to solve this question is to draw the horizontal line. The horizontal line denotes from T. This is the horizontal line. Okay, this is the horizontal line. And the information hereby, the angles of depression of A are 32 degrees. This is depression, right? This is the horizontal line, this one. Okay, okay, horizontal line. And the depression, it will be measured from the horizontal downward. 32 degrees, this one, right? Is it clear to you? So it means if we don't denote here is 32 degrees, automatically here is 32 degrees. Next, the angles of B from T is 43 degrees, this one. (43 degrees) means here is 43 degrees. Is it clear? Very easy, right? Okay. Okay, students. The drawing of 43 degrees and 32 degrees on the diagram is done. Okay, friends. Now we are going to solve this question. Okay, we are going to solve this question. Okay, right? The question is find the distance 80. 80 is one, right? 80. Let's say 80 is x. Right? Once again, let 80 is x. Okay? Okay, we say that 80 is x. Okay. And then the height PF of the building, this one, right? This is the height of the building, this one. Right. Okay, that's okay. No problem. Okay, students, we're going to solve this question by drawing. We're going to draw a game. The triangle ABT. Okay, this is the triangle ABT. Okay. The triangle ABT, this one. Okay. Okay, right? This is the triangle ABT. Yeah. A, B, and this one is T. This one is X, 32 degrees. This one here is 32 degrees. And this one automatically, we can find here, this one is 180 minus 43. Okay. We got here is 137 degrees. Okay. Okay, here this one. Okay. So you can say here is 137 degrees. Okay. And AB is 80, right? AB is 80. Very easy, right? I think we have to use sine rule to solve this one. Sine rule. So the sine rule is x over sine 137 degrees equal to 80 over sine. Oh, this one. We don't know yet about this one, right? This one. How many this one? Okay, we're gonna find here the angle is 180 minus 32 degrees minus 137 degrees. Okay, we got here is 11 degrees. Very easy, right? Because one triangle is 180 degrees. Okay, clear? So we can write here is sine 11 degrees. Next, x over sine 137 is 0.68 by using calculator, right? Equal 80 over, by using calculator, sine 11 degrees is 0.90. Okay, so we can find the answer by cross multiplication. 80 times 0.68 divided by 0.19. So we got x is 286.32 meter. Okay, we got this one right. X is 286.32 meter. Okay, that's very easy, right? By using the sine rule here. Okay, the next question is the height TF of the building. Okay, I think we have to construct again the height of the building. Okay, okay, this is the construction. Mhm. And it is TF, right? And this one is the construction. Okay, we can write here is this one is A, right? This one is F, and this one is T. Okay. The angle here is, we know that the angle is on A is 32 degrees. And then we know that x, here x already found, is 286.32 meter. Okay. Okay. The question is the height of TF. I think very easy by SOHCAHTOA, right? SOHCAHTOA. Okay. By using the SOHCAHTOA concept, I think we can use sine, right, to hypotenuse, right? So sine 32 degrees, sine 32 degrees equal to TF over 286.32. Sine 32 is 0.53 meter equal TF over 286.32. So automatically we found that TF is 151.75 meter. Okay, we got TF here. Okay, this one is TF. Okay, this is x. X is the representative of AG, right? AG. Okay. Okay, 80 is x already found, and then TF is 151.75 meter. Right? Very easy. Okay, this is the question one. Okay, students, we go to the next question. Question 2. 2 points A and B are 250 meters apart on the level ground, and H is a helicopter above the ground between A and B. The angles of elevation of A from A and from B are 37 degrees and 43 degrees respectively. Find the distance AH and the height of the helicopter above the ground. Okay, so then this question very easy. Okay, the first is we are going to draw the helicopter. Okay, let's say this is, I think this is the helicopter. Okay, let's say this one is the helicopter. The helicopter, right? Okay, this is the helicopter. Let's say this one is the helicopter, right? Okay. Yeah, very nice, right? The helicopter is very nice. This one. Okay. Okay, next we are going to draw. This is the ground. Okay, this is the ground. Mhm. Okay, this is the ground. And then the information A is 37 degrees. This one, right? This one. Okay, and B is 43 degrees. Okay, okay, okay. Now we notify here is A. This one is A, and this one is B. Okay. The information here is the elevation angle. So the elevation is from horizontal to upward. The horizontal to upward, we call that elevation. From A is 37 degrees, and from B is 43 degrees, right? Very easy. This is one, very easy. And the information is 250 meters apart, A and B. Okay, very easy, right? Okay. Find the distance of AH. Okay. For the first, we are going to find the distance here. So what is the concept you're going to use to solve this question? What do you think? Okay, to solve this question, the first step is we have to draw a height. Okay, we are going to draw the height. Let's say this one is height. Okay, we call this one is height. Here, this one is height. Okay, height. Okay, now we have two triangles, right? We call this one is C. We call this one is D. The helicopter is D, right? We have two triangles. The first triangle is triangle ADC, right? And the second triangle is triangle BCD. Okay, this is the first, and this one is the second triangle. Very easy, right? Okay, student, for both triangle, yeah, they have the same height, right? Height. For a triangle ADC has the height h, and then for triangle BCD it has the same height, right? H. Once again, the triangle ADC has height h, and the triangle BCD has the height as well, right? So triangle ADC and triangle BCD have the same height. Okay, by using the sine rule, I think. Okay, sine rule. Okay. Now we're going to the triangle ABC. Okay, this one. Okay, ABC. Sine 37 degrees is h over 80, right? Okay, and then sine 43 degrees is h over BD, right? But there's a solution, right? By using sine, there's no solution. Okay, what about tangent? Now we're going to use tangent here. Okay. This is the triangle BCD. Sorry, this one is triangle BCD. Okay, we have to separate this one. Okay, now we're going to use tangent. So what about tangent? For the triangle ABC, tangent 37 degrees, this one, is BC over AC, right? This one, for tangent is one, is it? Clear, everyone? But for the triangle BCD, okay, the triangle BCD, this one here, okay, tangent 43 degrees is DC over CB, right? Students, DC is height, right? So tangent 37 degrees is height over AC. And then tangent 43 degrees is height over CB. Okay? So how to notify AC and CB? I think that's very easy, right? Okay, so then let's say AC is X. Yeah? Let's say AC is X. 1. Okay? So automatically CB is 250 minus 8. 250 minus 8, right? Very easy, right? Once again, for AC is X, automatically CB is 250 minus 8, right? Okay, next here. Tangent 37 degrees is H over AC. And then tangent 43 degrees is H over CB. Okay, tangent 37 is 0.75. And then here is height over AC is X. Right? So by using cross multiplication, we got 0.75x. And the other side is tangent 43 is 0.93 by using calculator. And then CB is 250 minus X. By using the cross multiplication concept, we got 0.93 here times 250 minus X. We got it, right? Now we found that for triangle ADC, H is 0.75x, and for the triangle BCD, H is 0.93 times 250 minus x. Now we can write that H equal H. Is it? So 0.75x equals 0.93 times 250 minus x. Okay? Is it clear? Finally, by using the calculator, we found that x is 138.43 meter. Okay? Now, we already found the answer, right? We found the answer for x. X is AC equal 138.43 meter. And then for BC, for BC is 250 minus x. So 250 minus 138.43. Okay, we got BC is 111.57 meter. Okay, so this is the answer. Okay, this one. Okay, so what about distance AH? AH. The distance AH. That is very easy, right? Okay, students, now we're going to find the distance AH. AH is, I think, from A to helicopter, right? Okay, so AH is, based on the diagram, A to helicopter, we know it here is 80, right? Okay, so A is 80, right? So I think you can use the sine concept, I think. Sine 37 equal height over 80, right? Hmm. So sine 37 is 0.60. Height is, how many height? Have you got the height? Not yet. Okay, I think we have to find h, right? So here is this one, right? Uh, right. So h is 0.75x, right? So h is 0.75 times x. X is 1 times 138.43 meter. Okay. So for height is 0.75 times 138.43. We got 103. 103.82 meter. Okay, done. Okay, this one done. So now we're going to continue. Sine 37 is h over 80. H is 103.82 over 80. Okay, over 80. Okay, so by using cross multiply, so we got 80 is 103.82 divided by 0.6. We got 173.03 meter. Done for this one. So the distance AH is A to H, A to helicopter. We notify here is 80. Okay, this is 80. Okay, so 80 is 173.03 meter. Okay. Done.